In the previous section, we communicated between the FPGA and host PC using interactive front panel communication. By the end of this module, you will be able to execute an FPGA VI on either the FPGA target or development computer by selecting the execution mode for an FPGA target. Okay, let's talk about selecting an execution mode. So, to select an execution mode, what you would do is you would right-click the FPGA target in your Project Explorer window and select Properties, and it'll launch the dialog that you see on the screen. So, notice if you click the debugging category, there's two ways that you can execute that FPGA VI. One way is execute the VI on the FPGA target, which is that first option there. Now, when you're doing that, if you hit the Run button on that VI, what it'll do is it'll compile your code and it'll actually execute that VI on the FPGA hardware. Another thing you can do is instead of executing the VI on the FPGA target, you can execute the VI on the development computer. So if you take a look at that second option, if you're executing the VI on a development computer with simulated I/O, what happens is it doesn't send that VI down to your FPGA. It keeps it on your host computer and it basically uses simulated I/O so you can try to verify the functionality of your VI without having to compile. And we also see a third option down there with execute VI on development computer with real I/O. So you can also have an option of executing that VI on your development computer, so you don't have to compile yet, but you can actually use real I/O from your FPGA target if this happens to be supported on your FPGA target. So another way that you can select the execution mode is you can also right-click the FPGA target in your project and then just use a shortcut menu to navigate to execute VI on, and you can select your mode directly. And we'll see that later on in the demo. So once you've selected an execution mode, you'll see in your project that your FPGA target will tell you what mode it's in. So if we look at the very top one, notice that it says FPGA target, and that's pretty much it. If it looks like that, then what's happening is you're executing your VI on the FPGA target. So in this case, if you're running that VI, it's going to get sent down to your FPGA. If we look at that second item there, you'll notice that it says FPGA target and also says development computer. This tells us that when I run this FPGA VI, what's going to happen is it's going to just execute on my dev computer and it's not going to be sent down to my FPGA. So this is a very useful mode for you to make sure that all the algorithms and all the logic on your FPGA VI are correct before you go through the trouble of compiling it. So if you're executing your VI on your development computer with simulated I/O, you can either use random data for any FPGA I/O, or you can also use a custom VI for FPGA I/O as well. You can also, on some targets, you can also execute the VI on your development computer and use real I/O that's coming from your hardware. Okay, let's talk about testing with the development computer. So one thing I want to make sure you understand is when you're compiling an FPGA VI, that compilation can take from a few minutes to several hours. So it's something that will take a lot of time. So if you select your VI and you tell it to execute on an FPGA, it's actually going to go through this compilation process, which could take a long time. So that's why it's a good best practice before you ever execute your VI on the FPGA and compile it. You want to go in that simulation mode. You want to go and execute it on your development computer instead first. And this way you can make sure that the logic for your VI is correct, right? So if you look at the development flow that's shown at the bottom here, notice that you'll create your FPGA VI. Once you think you're done with it, then simulate that FPGA VI on your PC to test it. And then that way you can use all your debugging tools. You can use highlight execution, you can use probes, you can use single stepping, and that way you can kind of debug your VI and make sure everything looks correct on your simulation before you decide to compile it. Okay, so keep simulating, keep modifying your FPGA VI until everything looks good in that simulation mode. And then once you're done with that and you think everything looks correct and you've done your due diligence, then only after that execute your VI on the FPGA and then go through that compilation, which may take a few minutes to several hours. And that way you'll be able to save a lot of time by going through that kind of a development flow. So at this point, it would be good for you to be able to do exercise 3.1. So if you can, go ahead and do exercise 3.1, and you'll be able to create an FPGA VI and verify the functionality of the VI using the development computer. So you'll be able to get some experience on simulating your FPGA VI before you compile it. So right now, what I'm going to do is I'm going to go ahead and demo this and demo the solution just so you can get a high-level idea of what's going on with exercise 3.1 and also how to execute your VI on the development computer for simulation. Okay, I've opened up the solution for exercise 3.1. So let's take a look at this. So notice we have a CRIO target here, and we have the FPGA target that is under our CRIO. So we were talking about the execution mode. So one way you can take a look at the execution mode is you can right-click the FPGA target and go to Properties. This will cause this window to pop up. And then notice if you go to Debugging, you've got a couple of different modes. So Execute VI on FPGA target. Again, if you select this mode and run a VI, then it's going to compile it and send it down to the FPGA hardware. Another option is you can do Execute VI on development computer with simulated I/O. So this is a good option to use if before you compile, because you want to make sure you verify the functionality and make sure everything looks right on your VI before you decide to compile it. So notice that there's two options here. You can either use random data for your FPGA I/O. So if you happen to be using any I/O, it's just going to use random data. Or you can use a custom VI for FPGA I/O. So if you select that one, you can click on the Help button to get more information on that. So for now, I'm just going to leave it as use random data if I use any I/O. So now I'm going to click OK. Actually, I'm going to switch this back to Execute VI on FPGA target so I can show you a different way of configuring this. So the other way of configuring this, which is a little faster, is you can right-click on your FPGA target, go to Execute VI on, and notice right now it's executing on the FPGA target. Instead, I want it to be executing on my development computer with simulated I/O because I want to test it out first. So I'm going to select this, and notice now that it updates to show dev computer right here. Okay, so in this case, we've got our FPGA target, and someone has already developed a simple math VI. So because it's under the FPGA target, this VI is going to be my FPGA VI. So let me go ahead and double click it to open it. I'm just going to put that here. I'm going to show the block diagram. So right now, notice that it's going to be executing on my dev computer. Okay, so I should feel free to test it and use any debugging tools I want. Just to verify the functionality first. So let me go ahead and change this to 3 or 2. I'll change Y to 3, and I'm going to go ahead and run this. So now that just ran on my development computer, my host PC, and notice that x plus y is 5, x minus y is -1, and x times y is 6. So I've verified that it looks like my algorithm is correct, and I'm ready to go. However, let's say I didn't get my expected results and I need to debug it. Well, because I'm running this VI on my development computer, I can actually take advantage of all these debugging tools here. So I can hit highlight execution, hit run, and I can use that ability to debug my VI. I can also do single stepping, I can use breakpoints, I can use probes, and all the other debugging tools that are available to me on Windows. Okay, so this is a huge advantage of making sure you debug and test your FPGA VI on your development computer first. Okay, so now that everything's done, I can go ahead and close this. And if I verified everything looks correct, I can right-click this target, go to Execute VI on FPGA target, and once I've done that, when I open this VI and hit run, it'll actually compile it and send it to my FPGA VI. But we'll talk about that a little bit more in the next section. So note how quickly we were able to progress from development to testing, right? We had a VI that we created, simple math, and then we were able to start testing it and debugging it right away just by executing it on our development computer first. So have you ever tried troubleshooting a VI without using the debugging tools? So imagine you were trying to troubleshoot a VI and you didn't have the ability to single step, you didn't have any breakpoints, you didn't have highlight execution, you didn't have any probes either. Now, you can imagine that would be very difficult. And the point that I'm trying to make is once you're executing your VI on the FPGA hardware, when the VI is running on the FPGA, you no longer are able to use highlight execution. you're not able to use single stepping because the logic is already running on hardware. So just remember that, and by remembering that, we can remember the advantages of being able to test it on your development computer first. Okay, one is that you're going to be able to verify the functionality and make sure you're not compiling it for nothing. So first, make sure that your functionality is correct, and if it's not correct, you're going to be able to use your debugging tools to fix whatever that problem is before you decide to compile it.